it is, because this thing is so fast, you don't want a nurse sitting there taking a reading, putting it in the computer. That doesn't work. It doesn't work for you. It'll get boring in a big hurry.
Yeah.
You really want that to be automatic. And then you'll learn a whole lot from learning how to get a computer to control a valve or park a car. I mean, computers park cars now. It's part of I forget which ones have it.
Better than 15-year-olds sometimes.
Yeah, maybe. I wouldn't say that. But better than some.
I've never been in one of those cars, but I don't know.
I've seen them.
Yeah, they're really good.
They look. And what they have is a servo mechanism controlling their steering wheel. But they're just following a pattern. They're not. That's not feedback control. But the thing is, they're controlling. How you could get bogged down in getting the small computer or a limited computer to control a valve. That could be very limiting. I used to have a bunch of on-off switches. Do with those. You send a message through an RS-232 port, and you could turn a valve on and off. And in that way, if you had 10 valves for 10 different openings, you actually could do it.
Those are just binary, though, just on or off. It's
Yes.
not a very.
Right.
It's not a variable. You're better off with a variable. And then you have to, but you got multiple aspects of this project. One's defining the control math, and the second is defining how you get data in, and the third is how you're going to get data out, your decisions out.
Which part should they tackle first? I mean, I think they've gone and looked at some of the math.
Physiology doesn't exactly work perfectly together. Like it's not, it doesn't all relate like cleanly. They're not all in the same terms.
Which is not.
Like you can measure your hemoglobin level for that, and it'll give you a number.
Right.
It's a number, but that's not going to tell you what your oxygen saturation is.
No, right.
No, the primary thing you measure would be your saturation.
And your feedback is off that oximeter reading.
And as he built in things for kidney function, as an example, this might need to build in some sort of compensation for hemoglobin. So in theory, if your hemoglobin is lower, your saturations will drop faster, all other things being constant.
Is there,
But there's,
It'll drop faster.
right, because your oxygen content will be lower.
But your consumption of oxygen is the same, so.
But if you're delivering, the amount of oxygen you deliver will be proportional to the hemoglobin at a constant saturation. So if somebody's really anemic and has a low hemoglobin, their saturations will drop faster, even if they're using a similar amount of oxygen.
So
That might be one little mitigating.
So what he's saying is that the hemoglobin affects the half-life of a step change in on your input O2. And so when you describe your math, you just have to keep that in the back of your mind and decide whether it's.
And that's something we could probably find out as well. I think people probably look at that with it's the rules for transfusions basically. If your hemoglobin is 8 or higher, it probably doesn't matter until you get down below 8.
Mm-hmm. But then it's just that all it does is it speeds up the saturation response to an O2, which means there's going to be more noise. That means there's going to be more noise in the data, and it's in the half-life of the perceived change. In other words, you make a change in O2 delivery from that to that. Instead of dropping at this rate with low hemoglobin, it drops very fast. but you're gonna design this thing, for this half-life. No, you really need to design it for this half-life. Because if it's designed for this one, then this one's okay.
Yeah.
But you could actually be doing things more rapidly. So actually your time, your lockout time, the time when you're not changing, your data, my assumption when hearing, when you first described it, is you're gonna get O2 readings, O2 percentage.
So you can get those continuously, as you know, but you wouldn't want to change your oxygen flow continuously.
Right, but neither do you want to operate on the point value there. You really want to operate on the mean.
You look at a trend or mean or something.
Both, the trend and the mean. Because if the mean is here and the trend is there, you're going to increase. Or the opposite. So you're going to take all this data, maybe it's 1 every 15 seconds, and you're going to get a mean. And you got to decide how far back before you're making changes, before you make this next change. So you're collecting data over periods of time. So you have a time here that you're going to measure data and collect and get averages. And you can make this up for trial purposes and do and just have data and saturate it and get a mean, get a standard deviation and a trend, a slope. And if the slope is, well, if the slope is the same as the standard deviation, it just means there's a lot of noise. If the slope is 0 and there's a lot of noise, it's just a lot.
Now the better oximeters have a signal quality indicator on them as well.
And they probably dampen the results on the screen and on the number they present. The data they'll feed to the computer will be fixed at a certain time scale, and it'll be a certain amount of data. Or it'll be a certain reading, and then the computer picks the time. And then you decide, then that gives you a decision. That's part of where you are, so that you use the mean at this time. And the length of time here may be a function of the hemoglobin. That is to say, if the hemoglobin is low, if the hemoglobin is low, you cut this time down, and you do more changes, because you want to be a little more responsive if the hemoglobin is less than 8, let's say. But that's a fine point.
Yeah, I think you have to build it for normal.
Normal response.
Well, I'd build it for a normal hemoglobin to start with, and then build out exceptions from there. But there are some people, you guys haven't seen this data, we haven't talked about it, but some people start at 95, and within 2 minutes they're 80. There are other people that start at 95, and within 2 minutes they're still 95. And in 6 minutes they're 91. And so there are very different slopes there.
You mean when you cut the oxygen off?
Or as they're exercising or that sort of thing.
Yeah, what other factors are they gonna run into?
Well, that's another factor he just mentioned, oxygen consumption.
Right, which,
So you have, if you're going to use this while somebody's exercising, you're going to apply it to a physiologic situation where somebody's walking. You actually want to increase the oxygen when they're walking, they're consuming more.
Can we get data from the rehab?
Yeah, although I can make it up as easily.
Your best bet to start off is to use made-up data. You could spend a lot of time gathering quality data and not quality data, and you just spend a lot of time.
It's easy to make data.
You just
Well,
need to
and
get
when
your
someone's
hands
awake
around
and sleeping.
what you're doing and then how you're gonna respond. Let's say you make a change. Let's say you got a mean here that's